Hi, this is Ken Rosever. We're going to talk about how to write an equation of a circle given its center and a point on the circle. So basically what you're given here is, here's a circle, not a very good one, and they're providing you with the center and one of these points. And from that information, we're trying to determine the equation. Um, is that sufficient? Yeah, it is. Because if you have the center and a point, you can solve for the radius. And if you know the radius in the center, you can write the equation. So basically, we're going to try to write this thing in standard form, which is x minus h squared plus y minus k squared equals r squared. And in order to do that, we can go one of three ways with the information we've been given. One of our options, well, let's graph these points first, and then we can look at our options. Um, negative 3 comma 1 is an actual point on the circle, so I'm going to put that as a dot. Negative 3 comma 1 is right there. So that's negative 3 comma 1. The center of the circle, they're telling me, is at 0 comma 2. So 0 to the left or right, up 2 is right there. And technically, as I do that, it would be more, ooh, wow, I don't like that. Um, I don't know if I can erase that. It would be more correct if I did that as an open circle. So let me delete that one. Okay. Because actually the center is not included as a point on the circle. It is a point of reference within the circle. So there's our center, and it's at 0 comma 2. Let me do one last thing here. I don't like that. I'm wondering if I can move just okay, I'm just going to leave that unmarked because I'm going to need to write some other stuff there. All right, keeping that in mind, how are we going to figure out R? Well, we have a couple options. Geometrically, when you look at this thing and you want to know the distance between 2 points, you know that one option is the distance formula. The distance formula is an equation that's based on Pythagorean's theorem that says the distance between any 2 points is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. But what you'll notice there is it bears a striking resemblance to this formula over here if you think of that as being x minus h squared plus y minus k squared. And if you square root r, you'll have a big square root there. So both of these formulas actually come from the same formula. They come from the Pythagorean's theorem. A squared plus b squared equals c squared. And the idea is if you have the center of a circle and any point along its edge, that by definition, every point on that circle, any x comma y, is a set distance called r away from the center, which is h comma k. So if you measured the distance from here over, that would be your change in x, or it would be x minus h. Whenever you're doing a change in value, you do one value minus the other one. And then this one would be our change in y, which would be y minus k in this case, y minus k. Um, and if those are your lengths, using Pythagorean's theorem, you would have change in x squared plus change in y squared equals r squared, or x minus h squared plus y minus k squared equals r squared. So all of these formulas are related to the Pythagorean theorem. So you have three options when you're trying to answer this question. But really what I want you to understand is while the options may look different at first glance, they are actually all related. So I'm going to go with the easiest one here. If you've graphed the points, the easiest option is to use Pythagorean's theorem. Pythagorean's theorem says if you have a something like this, and this is your r, and you're looking to find it, then you need to know this length here, and we can see it's 1, 2, 3, and this side over here, because it's the leg squared plus the leg squared equals the hypotenuse squared. And in this case, the hypotenuse is r. So if we're trying to find r, we can go 3 squared plus 1 squared equals r squared. So that's 9 plus 1, or 10, is r squared, which implies that r is a square root of 10. So that's one of your options. Your other option, and this is the case on all equations, if you have 4 out of 5 inputs, then if you put in the 4 inputs, you can solve for the 5th one you're missing. And what we have here is 4 out of the 5 inputs. Right here we have a point. This point will be a solution to the equation I'm looking for, so it is a valid x comma y for the equation I'm trying to find. This point right here is the center of the equation I'm trying to find, so it is h comma k in that equation. So I can plug in for x, I can plug in for y, I can plug in for h and k, and that'll leave me with just r squared. So another option you have is take that equation, the general form of a, or the standard form rather, of a circle, and plug in your inputs. X is -3, h is 0, y is 1, k is 2, and we're going to solve all that, and that'll be r squared. And you can see -3 minus 0 is -3 squared is still 9. 1 minus 2 is -1, and when we square that, we still get a 1. So we still get 10 for our r squared, which means r is still square root of 10. And once you know r, since you have everything else, you can just write the equation of this circle, which I haven't really drawn here, but it would look something like this. Let me try to plot some points. All these points would be on it because I'm just following that same pattern of either up 1 and in 3, or out 3, up 1, just following that pattern. These would all be points on that circle. Not the best picture, but there's a circle, and the equation of that circle, I'll use a bolder ink here, would be x minus 0 squared plus y minus 1, not 1, minus 2 squared equals r squared, and r in this case, r squared is 10. So that would be your answer. Or you could say x squared plus y minus 2 squared equals 10. And that's it. That's how you do it. You can use that. You can use the general form of the, or standard form of a circle. You can use Pythagorean theorem. Or if you really wanted to, you could use distance formula, which of course comes from that same idea. Distance between any 2 points will be, this will be change in y, this will be change in x. Here's the first point, here's the second point, and this will be the distance. So Pythagorean's theorem says that d squared is going to equal delta x squared plus delta y squared. And that's where that comes from when you square root both sides. So that's it. I hope this was helpful, and that you got a better understanding from watching it of circles. Bye.